The video here is for section 5.3, which is on stoichiometric calculations. So in the last two sections, section 1, we balanced equations. In section 2, we looked at writing mole ratios, and I told you we were going to use that to do some calculations here. We are going to combine those two things with solving for moles, which we did in basically all of Unit 4. And wrap this up in kind of the main point of chemistry. I mean, if there was one section to take away from this entire year, it's really stoichiometric calculations. If you can do this and you understand what's going on, second semester will not be bad for you. If you're struggling with this, you definitely need to make sure you understand it. Come get help. Okay, but this is kind of the main goal of why we even teach chemistry, is for you guys to understand this. So, stoichiometric calculations. Okay, so there are different types of stoichiometric calculations. There's 1 step, 2 steps, and 3 steps. I'm going to show you the order in which to solve them, and it should not, if you follow that, you should not make any mistakes. So a stoichiometric mole-to-mole conversion. So the mole ratios and the coefficients can be used to determine amounts of substances present before and after a chemical reaction. In the last section, that's what I talked about. These numbers out front, which we call coefficients, okay, they tell you how much stuff gets made, but remember that is in moles, right? In the real world, we don't deal with moles because we don't have a scale that measures moles, but we have a scale that measures mass. So we can use mass to figure out how many moles are present, figure out what sort of ratio things are going to react in moles, and then convert it back to mass to figure out how much we actually made. So right, we're using an example here. 2 moles of potassium plus 2 moles of water plus 2 potassium hydroxide is going to give us 1 mole of hydrogen gas. So right, for every 2 moles of potassium, we yield 1 mole of hydrogen gas. But what if we only had, like, I don't know, 0.0400 moles of potassium? Okay. All right, now maybe you can do this math in your head, but what if, again, the numbers aren't like as straightforward as 2 and 1? Then we're going to use mole ratios and stoichiometry to figure out what that number actually is. So, kind of showing you the basics of this, and then we'll talk about how we solve them, and I'll give you the steps for it, and you definitely want those steps in your notes. If you can follow it and understand what those steps are talking about, all right, we'll do plenty of practice with it. You should be in good shape. So the questions are going to start looking like this. It might say something like, how many moles of hydrogen gas is produced when 0.0400 moles of potassium are used in the reaction? So it'll give you this. It'll say how much H2 gets made if I start with 0.0400 moles of something, right? This one or this one. I'll specify what it is. And by the way, from now on, like when it comes to units, you have to specify whether it's moles or grams and what substance it is. Okay, if you fail to do that, you are not going to be able to follow along with units canceling. Again, that's what the last section told you needed to do. We're going to be canceling units. It's the whole point of this. Okay, so starting with 0.0400 moles of potassium, how much hydrogen gets made? Well, what you want to do is just start by writing down whatever information is first given to you. The moles of whatever is known here. We know that we have 0.0400 moles of K, so we start with that. And we are going to multiply by, okay, here is the mole ratio. Okay, this whole thing is the mole ratio. And we're going to put the unknown substance, the one we're solving for at the top, over the known substance, the one we were given on the bottom. Okay, so I write it as unknown over known. You could write it as what you are looking for over what you were given. Here we are given potassium, right, where you were given that value, so that's going to go on the bottom. And on the top goes the moles of whatever is the unknown, what we're solving for, which in this case is H2. So you have to set up this mole ratio in all the problems. As long as you know it's what you're looking for over what you were given, if you want to call it unknown over known, that's how this sets up. So it's going to be moles of your unknown over the moles of what you were given, or the moles of the known. Where do those numbers come from? Those numbers come from the balanced equation, right? Okay, so right, if there's nothing there, remember it's 1. The thing we are solving for, the thing we are looking for is H2. Well, if there's no number in front of H2, it's 1. So this is 1 mole of H2 across the top divided by, okay, on the bottom is the moles of the known, moles of what you were given. Well, that's 2. Okay, so 2 moles of K. So this is 0.00400 moles of K times 1 mole of H2 over 2 moles of K is going to give us 0.0200 moles of H2. All right, don't forget to include significant figures with your answer. And just to show you why this works, look at this. Moles of K cancels out, right? Okay, so that's why we do this. We're all canceling units. These are the simplest types of stoichiometry problems to solve because these are one step. All you have to do is just take what you are given, okay, and multiply it times the mole ratio. All right, this is mole to mole, mole to mole. All right, this is just one step conversion. Okay, we'll see what two-step conversions look like or three-step here in just a moment. But what we're going to do is just take that balanced equation. If it's not balanced, you have to balance it. And then we'll see these steps of things that we need to do here on the next slide, which you definitely want to get into your notes. Okay, so steps for solving stoichiometry problems. Step 1, if the reaction is not balanced, if the equation is not balanced, it needs to be balanced. If it's not balanced, there's no way you can get this correct. So that's the first thing you got to do, okay? And hopefully you are good at that at this point. Number 2 is convert the starting substance to moles, that is, if it's necessary. Sometimes, like the last problem, it's already in moles. So if you are in moles, you don't have to convert to moles. But if it gives it to you in grams, okay, so if it gives you a starting substance in grams, guess what you have to do? You have to divide by the molar mass of that starting substance. Okay, so do that, you get the number then in moles. Step 3, multiply by the correct mole ratio. Which is what we just saw on the previous slide, right? It's the unknown over known, or if you want to think of it as what you are looking for over what you were given, either way. And those numbers come from the balanced equation, okay? We'll say from balanced equation here, just so we make sure that that's correct. From the balanced equation, okay. So then you'd be in moles of what you are looking for. And then finally, to convert it back to grams, if the problem says convert it to grams or give me an answer in grams, then you would multiply by the molar mass of that final substance. Okay, so there's really only these 4 steps. Balance the equation if it's not balanced. 2, convert the substance to moles if it's not already in moles by dividing by molar mass. 3, multiply by the correct mole ratio from the balanced equation, what you're looking for over what you were given, unknown over known. Those numbers come from the coefficients in the balanced equation. And 4, convert back to grams if the problem says to convert back to grams. Okay, so we're going to see an example here and go through these steps. Okay, so this is a 2-step conversion problem. This is moles to mass. It could be mass to moles as well. But let's just read it and see what we need to do. So how much H2 gas is produced in grams? So it wants an answer in grams, not moles, from 0.0368 moles of K. Okay, so always start by writing down whatever number we were given, moles of K, right? And we need to make sure that our units are very descriptive, moles of K. Okay, so first step is to see if the equation is balanced. Is it balanced? Yep, it's already balanced, don't have to do that. Step 2 is to convert the starting amount into moles if it's not in moles. Well, we were given a value in moles, so we do not need to do step 2, which would mean divide by molar mass. We're already in 2 moles, so we don't have to do that. Okay. Step 3 is to multiply by the correct mole ratio. All right, so it's going to be moles of something over moles of something. What we were given always goes on the bottom. Well, we were given moles of K. So if you want to think of it, we're just immediately getting rid of it. So that's going to go down to the bottom. Moles of K. Okay. And then across the top is what we're looking for. We are looking for H2. Okay. And those ratios from the balanced equation up here, we have a 1 in front of H2 since there's nothing in front of H2. And we have a 2 in front of K. So my ratio is 1 over 2. And that'll finish up step 3. Step 4 is to convert back to grams if necessary. Do I want an answer in grams? Yes. So I do need to do the 4th step, which is going to be multiplying times the molar mass of the thing I'm looking for. I'm looking for H2. H2's molar mass is 2.02 grams for every 1 mole of it, right? 2.02. Each hydrogen is 1.01. And then that is going to give me my final answer. But before I type it into a calculator, I do want you to see that these things all cancel out. Moles of K cancel. Moles of H2 cancel. I'm left with grams of hydrogen gas as a final answer, which is what the question is asking for. So I have 0.0368. Basically, this is divided by 2, or times 1/2, however you want to type it in the calculator, then times 2.02. Now, those two things are going to just about cancel each other out. Not quite, because we're multiplying times 1/2 and multiplying times 2. My final answer should have 3 significant figures. I have 3 here and 3 here. These are exact values, so we don't include that into figuring out how many significant figures my answer will have. And this should be 0.0372, and my unit is grams of H2. Okay, so there's the answer to that one. We call this a 2-step problem because how many steps did we have to do along the way? 2, right? Okay, so before we only had to do the mole ratio one in my last example. This one, 2-step, and then we'll do one example of a 3-step one. Okay, here we have a 3-step problem, mass to mass conversion. How much potassium in grams is used in the reaction below if 0.629 grams of H2 gas is produced? Okay, so we'll start by writing down what we were given. We were given 0.629 grams of H2 gas. Okay, we are looking for grams, and we were given a starting number in grams. That is going to be a 3-step problem where I have to go from mass of one substance to mass of another substance. So the first step here, right, writing that down. Second thing to check is my equation balanced? Yes, it is. Okay. The next thing to do then is to see, is my starting substance in moles? The answer is no. It's in grams, so I have to convert it to moles. Well, that would be dividing by molar mass. What I'm going to do is write it like this, though. Okay? And the reason being is I want you to see all the units canceling out. Yes, this is still dividing by molar mass, 0.629 divided by 2.02. Okay, but I'm writing it in reverse. 2.02 grams of H2 for every 1 mole of H2. Okay, that's just the molar mass there. So that's the first step. All right, now I'm into moles. That would put me into moles. Notice my units as we go. I'll cancel them as we go this time. Grams of H2 cancels out. I'm in moles of H2. Once you're into moles, you can do the mole ratio, what you're looking for over what we were given. We were given H2. We are looking for K. Okay, those numbers from the balanced equation are 2 over 1, right? There's nothing in front of H2, so it's just a 1. So that's the second step in the 3-step problem here. And then lastly is convert it to grams if it wants an answer in grams. So the last thing to do then is to multiply times the molar mass of the substance we are looking for, 39.10 grams of K for every 1 mole of K. I'm just pulling that off of the periodic table. Okay, that's step 3. I should have canceled my units as we went. That's all right. Moles of H2 canceled. Moles of K cancel. And the only thing I have left then is grams of potassium. Okay, so then typing this into the calculator, 0.629 divided by 2.02 times 2 times 39.1. Okay. I need 3 significant figures for the answer. This should be 244 grams of potassium there. So you need a lot of potassium just to make a few grams of hydrogen gas. Okay, so don't stress out about these problems. A lot of kids immediately, they see these things, they freak out, they go, oh my gosh, I don't know what to do. You have an example here of how to do all the 3 different types. A 1-step, 2-step, or 3-step problem. Okay, when in doubt, go back to your steps. Okay, the first thing you should do, just right after you write down what number you were given to start with, make sure the equation is balanced. Convert it to moles if it's not already in moles. You always multiply times the mole ratio, no matter what type of problem. All stoichiometry problems have a mole ratio that you have to multiply by. Okay, that's this one right here. and then convert it back to grams if the answer needs to be in grams based on what the question is asking. That would be step 3. We will do lots of examples together, and you will do a lot of examples this semester and next semester. You guys will get this down, okay, no matter what. We will have plenty of work with it. But if you get stuck, okay, come ask for help, all right? This is an absolutely critical part to chemistry. So